Hello everyone. So in this video, I will be discussing the differences between struct and union in detail with the help of an example. So let's begin. So first, what is a struct? A struct is a hierarchical collection of different data types and its members are stored in different memory locations. So this makes it ideal for data packets where multiple values of different data types belongs together. And the size of a struct is the addition of size of all of its members. So allow me to demonstrate that how to write and initialize a struct. So I will begin with naming my module. I will name it test. So for this example, first I will define a struct data type. So I will just write type def struct and I will just use curly bracket, and the declaration of struct is kind of similar to module declaration because for each of the members you have to write the data type. For example, my first member should be of int, so I will write int and the name of that member, and then it is followed by the semicolon. So it is kind of comparable or very similar to what you will see inside modules netlist. Oh, I should not say netlist, I should say net declaration. Okay, so let's give another member a byte data type and the other member, let's say short int, and the other member int. So I will name this struct the type of this struct my struct, and here I will just declare that struct. So as you can see right here that it is just a collection of different data types, and each data types are stored in different location, even though each of these members, so everything inside this struct is called member because all of these are the member of a single struct, and each member can be of different data type. As you can see right here, the first member, which is A, is of int data type. The second one is of byte data type, and the following ones are of short int and int data type respectively. And each of them belong to a single data structure. So this makes it very simple when we are transferring some value. Uh, like, for example, I've already mentioned that it is ideal for data packets because multiple values of different data types belongs together. So if you want all of this struct to be stored in the same memory location, or if you want all of these structs to be set of contiguous bits, you could just use the keyword packed right here. So what this will do, like each of these struct will be a set of contiguous bit. But for this video, because our main focus is to describe the differences between struct and union, I will not go through pack struct, and instead I will make another video. So this is how we declare a struct, and I can just go ahead and assign any values to that struct right here. And it is very similar to what you will do with arrays, or I mean dynamic arrays or the normal arrays or queues. So you could just write the tick and curly brackets, and inside that you can write the values in the same order as per the members of the struct. So for example, for the first, I am giving int 32-bit value. I will just write the number right ahead. So let's give it 102. And for the second member, I am giving 8. For the third member, I am giving 19. And for the fourth member, I am giving 112. So just by this simple initialization, we have assigned these values to this to their respective members, and it is determined in at what position you have written the values. So why don't we just go ahead and print the values using %p? I will use $display %p and the name of the struct. Oh, I forgot to mention the name of the struct. So my struct is a custom data type which I have created right here using type def, and I am just declaring that type, and with that type there should be a variable. So I am naming it my st. Very simple. Okay, mst. So I will go ahead and I will first check for any compilation error. Okay, there are 3 errors. What did I do? I will just Okay, it's a typo right here. So I will go ahead and check for any compilation errors again. Okay, there are no errors. So this was the root cause. So let's go ahead and simulate the code using my run.do file. So as you can see right here that the %p is printing every member of the struct with its respective labels or whatever you want to say it. So it's very simple and straightforward. So what if I have used packed right here? So if I've used packed right here, so pack will make every member to be contiguous. So using that, each member will not be stored in different memory location. So I can just go ahead and use use D for decimal, and I can go ahead and print the value. So it will print every value as a single entity. So let's go ahead and print it again. So as you can see right here that we are having a strange value, and it is because it is nothing, just it's just the continuation of all of these values together, because I have used the pack keyword, which packs all the members together in a single memory location. So this was the simple initialization of struct. And here inside initial block, we can just we can again just assign the value by using this. And we can also refer to a single member and assign the value to that member. And I will show you. So let's say in the next time slot, I will just write mst. And suppose I want to change the value of the member B. I can just write here mst dot, and I will write B, and I can assign any value to that. Let's assign 17. And then I can go ahead. Oh, instead of this, I can just use monitor. And let's go ahead and run the code for one more time. Okay, so my run.to file is failing, and it is because of the fact that here I am using %d. So the %d will work if the struct is of packed data type, but here we just reverted our struct back to unpacked type. So I should use %p. I will go ahead and run the code. So as you can see, when we just reference the member B and we assign 17 to that member, and using the dollar monitor we can just find the change right here. So let's move on to union. So what is a union? So similar to struct, it is a set of different data types, but here the set of different data types is used for different contexts, because in union we are using different data types to access the same data. So it stores its member in the same memory location, and the size of the union is equal to the size of the largest member. So I will show you how does it differ from struct. So I will define the union data type, and here I will assign two members, and it is very similar to struct, just like you will find inside the net declaration of module. I will begin with a member, and I will name the member X, followed by a semicolon. Then I will name another member. I will name it Y, followed by a semicolon. Then I will name the union, let's call it num underscore u. Then I will declare the union right here. So here the difference is that it also have different data types. It can have different data types, but all of this member are referencing to the same value, to the single value. So unlike this, each of the members are not stored in separate memory location, and in fact it is not collection of contiguous bits like in the case of packed struct. It is just referencing the same value using different data type. So you can just go ahead and assign any singular value to the entire union, and you can just display that union using the int type, using the x. And if you display it like this, like un.x, then it will print the value in int type. If you display the value using int.y, then it will print the value using shortened data type. So allow me to demonstrate this. So right here in the initial block, I will assign a 32-bit value to the member x, and it is very similar to struct. You just have to write the name of that union dot the name of that member, and then I will assign some random 32-bit value. Let's assign 62, 45, and 0987. Okay. So now what I will do in the next time slot, I will just display the value of that union using $display. But I will display the value of each individual members. First, I will display the value of member X. Then I will display the value of member Y. And I should also mention it right here. It will become much and more convenient. So just observe right here that, okay, I don't know why I've written, okay, it's for, never mind. So just focus right here that I am assigning the value to the only first member, which is X. And the first member is of int data type, and int data type is of 32 bits, and the size of a short int is 16 bits. So I have assigned a 32-bit value to that int type, and it is basically assigned to both of the members because both of the members are pointing out to the same memory location, to the same element, but the difference is that uh, the the representation is different because the data types are different, and the total size, the size of this union, it will be equal to the size of the largest member. So here the largest member is int the x, because x is of type int, which is 32 bits in size. So I will go ahead and run the code. So as you can see right here that I have only assigned a 32-bit value to the member X, but still, because both of the members are pointing towards the same data or the same memory location, the value is also assigned to the member Y. So I haven't assigned anything to member Y, but it is still printing the value. So this is nothing, this is just the short int representation of this 32-bit value, which I have assigned to the member X. So that's all for struct and union. Just remember that struct is a collection of different data types, and those different data types are stored in different memory location. And if you just use the keyword packed right here, those members will still be different, but they will be stored as a set of contiguous bits. And unlike struct, union is a collection of different data types, and those members are used to reference to the same memory location or to the same data. So that's it for struct versus union. Stay tuned for more. Thank you so much.